Welcome to today's video. In today's video, we are going to take up the chapter Chemical Kinetics, which is your physical chemistry's last topic. This chemical kinetics. It's a very easy chapter and completely formula based. With a little bit of brain, if you use in this chapter, you can easily score marks in the chapter. So let's start very quickly with chemical kinetics. The first thing we need to know is what is kinetics? Kinetics you have learned in physics is defined with some movements, right? Kinetics, 1D motion, 2D motion, these are all kinetics. So kinetics is somewhat related to the rate. It is related to the rate of change of something or movement of something. So in chemistry, chemical kinetic means what is the rate of change of a reactant or product in a chemical reaction. So the kinetics of a chemical reaction will be studied in this chapter, which is known as chemical kinetics. First and the foremost thing we will define is what is rate of a reaction. This is the first thing we need to know. What is rate of reaction? So tell me, what do you understand by rate of something? Suppose I ask you rate of change of velocity. Rate of change of velocity means acceleration. Rate of change of velocity means acceleration, right? So velocity is changing means what? With respect to something, the velocity must be changing. So with respect to time, the rate of change of velocity will be defined. So we write it as dvdt, which is nothing but acceleration, right? So this we have learned in physics. So similarly in chemistry, we will not deal with velocity, we will not deal with acceleration, we will not deal with force, we will not deal with mass. We'll deal with mass, but in not that way anyway. So what is rate? Rate means the ability to do something, and rate of a reaction means the ability of the reaction to happen, the ability of the reaction to happen. So we cannot say like that. So rate of reaction we in chemistry have defined as the change in the concentration of products or reactants. Clear? Rate of reaction means the change of concentration in reactants or products. Just a minute. Change of concentration of reactants or products. So rate we can define using any of the case. We can take up the reactant and say this is the rate of the reaction. We can take up the product also, we can say this is the rate of the reaction. Understood? This rate we have defined into two terms. One is called average rate of reaction, average, and one is called instantaneous. Definition not required at all. Instantaneous. No need of any definition. Just remember, average rate of reaction means the rate of reaction which is taken as a like entire reaction is happening. So at an average time we have taken it. And instantaneous means at a particular instant. Best example is this average velocity you have learned in physics. Average velocity and instantaneous velocity. So what was the difference between instantaneous velocity? Instantaneous velocity is a velocity which is measured in a very short duration of time. Suppose a car is traveling a distance of 600 km in 2 hours. So at let us take at 340 seconds, what is the velocity? Then that will be the instantaneous velocity, because at that instant I want to know. Similarly, if I want to know the reaction's rate at a particular instant, then that is instantaneous rate. So what was the difference? This would have written as delta t, delta x by delta t, right? That means the total displacement by total time taken, and easily we will write dx by dt. Since x tends to very small, t tends to 0, then it will become dx by dt. Clear? So similarly here also we will remember it as delta x by delta t, means here it will become delta concentration by delta time and d concentration by d time. Clear? So let's write it down. Average velocity, average rate of reaction. Velocity I am also telling anyway. Okay, average rate of reaction will be termed as d concentration by dt, not d, delta concentration by delta t, and this will be called as d concentration by dt. Okay, mostly we will use the d only because we will talk about the instantaneous only in most cases. Clear? Acha. Writing concentration should be always in a bracket. Concentration of suppose a substance A, then this will be called as concentration of A. So whenever you are writing concentration of A, then you will be writing using a third bracket. Clear? Okay. So understood what is rate of reaction? Rate of reaction divided into two types, average and instantaneous rate. Understood? Okay. Now how to write this rate? How to write the rate? See here, rate of the equation. Suppose there is a reaction A plus B forms C plus D. So now you tell me, in this entire equation, if I multiply this with A, this coefficient B, this coefficient C, this coefficient D, Okay, coefficients are this. So the rate of reaction can be explained in two ways. One can be expressing in the terms of the reactant, other can be expressing in the terms of the product. So if I want to express in the rate of reactant and reaction of product, then how will I understand whether it is the reactant or the product? I don't know the reaction. Suppose I don't know the reaction, then I should be able to know that I have written in terms of reactant or I have written in terms of product. So to differentiate between the rate of reaction of product and using reactant, we will use a minus sign for the reactants. Why? Because reactant concentration always decreases with time. If I talk about product concentration, then it increases with time, but reactant concentration decreases with time. So whenever we are going to write with the reactant, it is definitely going to decrease. Clear? So how to write the rate of the equation? How to write the rate of the reaction? The rate of the reaction will be written as like this: minus 1 by A dA upon dt. Clear? Or you can also write delta A upon delta T. That does not matter over here. Okay, equal to, or generally we use D only. You can also write delta, I am telling you, no problem. If you write delta, will get marks. If you write D also, will get marks. Both the ways. Okay. Acha. Minus 1 by B dB by dt. Okay. Equal to, since this is a product, then I will write plus dC by dt. Okay. Equal to 1 by d of d by dt. Clear? Understood? So this, if you want to write in a form of delta, then what will you write? Simply just replace it by delta. So 1 by A delta A by delta T equal to minus 1 by B delta B upon delta T equal to 1 by C delta C upon delta T equal to 1 by D delta D upon delta T. Clear? So this is the rate of this equation. Writing the rate of equation is, so what you need to remember from here is, whatever is the coefficient, that will be divided simply. If the coefficient is 3 by 2, then you will have 2 by 3. So whoever is the coefficient of that particular reactant, that will be simply divided. This is the entire rate of the equation. Clear? Rate of this reaction is written by this way. Understood? This minus sign only signifies that the concentration is decreasing. I am writing minus, shows that concentration of reactants, actually not reactants, shows that the concentration of that particular substance A decreases with time. Clear? So it decreases with time, that means it must be a reactant, because product's concentration cannot decrease with time. Understood? So this minus you are just going to put so that you can understand, but you will not give an answer in terms of minus. That's not correct. So you are not going to give an answer in terms of minus, but you have to use it when you are writing the equation. Otherwise the equation marks you will not get. Okay, next. Next, there are some factors affecting rate. There are some factors which affect the rate of reaction. Factors affecting rate. So what are the factors that will affect rate? We are just going to define the factors. Number one, nature of substance. Nature of substance. Which substances will undergo a faster rate of reaction? There is actually substance, or we can say that substances are basically the reactants. Okay. So nature of the reactants. Anyway, so which substances if we use will give a greater rate of reaction? Ionic substance. We will use ionic substance, then it will give me a better. Why? Because ionic substances can form ions in the solution which react very fast. Clear? So if we use ionic or polar covalent compound, then also it will work. But non-polar covalent compounds will not be acting as a very effective rate of reaction. It will not act as a very high, it will not give a very high rate of reaction. Understood? Simple reasons, because they are non-polar. So non-polar reacting very fast. Understood with this? So nature of substance, reactants should be either ionic or should be polar covalent. Next, concentration of the reactants. This is obviously important. Concentration of reactants. So if I increase the concentration of reactants, my rate of reaction also should increase, but it should be not exceeding too much. Okay. So if I increase the concentration, if I increase the concentration, my rate will also increase. If I increase my concentration, the rate also increases. But we cannot assure you that it will increase. Might not also, but generally and mostly it increases. Clear? So proportional to rate, directly proportional to rate. Clear? Next, temperature. Next, temperature is an important point. If I increase the temperature, there also my rate will increase, and that is obvious. We'll talk about this later on when we read about Arrhenius theory or rather collision theory. Then we will talk it about. When temperature increases, collision between reactant molecules increase. As a result, products, their transformation into the products also increases. This is called collision theory, which we will read it there. Okay. Similarly, in concentration of reactants also, if I increase the concentration of reactants, then more reactant molecules, more collision, rate will be increased. Clear? Next comes surface area. If I increase the surface area, then also my rate will increase. And this is the best example, you know already. Surface area. That is your photographic film. Photographic film, na? Which you have AGBR and AGCL. There also, if surface area is provided more, then reaction will happen more. And this photochemical decomposition will happen more. If you decrease surface area, then your photochemical decomposition will decrease. Your photo quality will go bad. Clear? Next comes another very important point, that is catalyst. Catalyst increase the rate. Okay. Actually, saying that catalyst increase the rate is wrong because there are some negative catalysts also. So please put a star mark over here and make an alert mode. Oh, color did not. And be on alert that all catalysts do not increase the rate. Can come in adversarial reasoning. Catalysts increase the rate of reaction. Which catalyst? Only positive catalyst. So here you note negative catalyst or catalyst poison. Negative catalyst slash catalyst poison. Decrease rate of reaction. This you have learnt in class 10. If you use catalyst poison, then so don't use negative catalyst or catalyst poison. So please remember that in general we never use that, but maybe in adversarial reasoning this point of view can be considered also, that all catalysts do not increase the rate, negative catalysts do not. Clear? Positive catalysts and other catalysts definitely they increase the rate of reaction. Clear? How they increase the rate of reaction? That we will discuss a little bit later in the chapter. Okay, is it clear? Is it clear? Do you have any other doubt till now? No. Understood all this? Now let us move on to the next topic. The next topic is getting towards the integrated rate equation. Note that we learned some terms. First terminology that we will learn, you have learned in class 11 another law which is called law of mass action. If you remember the law of mass action which you have learned in class 11, which chapter? Chemical equilibrium. In chemical equilibrium in class 11 you have learned the law of mass action states that rate of equation. I am not writing the law because it is there in the book, so please read. And it is not possible for me to write also now. Okay, rate is proportional to, the rate of a reaction is proportional to the product of active mass of the reactants. So if the reaction is A plus B forms C, then active mass of reaction is this one. Let me write the reaction and see what is A, what is B. So if the reaction is A plus B to some product, then according to law of mass action, rate of the reaction proportional to the product of active masses of the two reacting components with their powers raised to the stoichiometric coefficients. Okay, with power raised to the stoichiometric coefficient. So if the stoichiometric coefficients are x and y, okay, xy plus yp, then their power will be x and y. This is according to the law of mass action. Okay. Now you will say, well, what is active mass? Then active mass is basically nothing but the concentration. So if you ask me what is active mass, then I will say active mass is nothing but the molar concentration. The molar concentration. So whatever is the concentration value given, just put it in the question paper. Okay, just put it in your answers. Did you understand? Did you understand? So if a general equation is asked, and you are asked that tell me what will be the law according to law of mass action, what should be the rate of the equation. We have to write rate proportional to A coefficient and whatever is the reactant, that coefficient will be raised. Clear? Clear? So law of mass action is a theoretical concept. Remember this. Law of mass action is a theoretical concept. It is a theoretical concept. Why? Because by using the equation only I have written this. Xa plus yb rate proportional to a to the power x by b to the power y. Now when experiments were done, it was seen that for one reaction, whatever is the theory the coefficient was given, that is not matching with the experiment's value. Experimental value is not matching. How? That means there is something which is determined experimentally but not theoretically, and that thing will be called as rate law. So rate law or rate expression. This rate law is an experimental value. Is an experimentally determined. This value is experimentally determined and it is a mathematical expression of the concentration of the reactants. Clear? It is a mathematical expression of the reactants. And this cannot be found out in using the theory. That means you look at the equation and you tell me the rate law, you cannot do that. Very sorry, you cannot. Clear? Because it is experimentally determined. So if I write the same equation, XA plus YB forms some product, then rate equals to K times A to the power Y, to the power alpha and B to the power beta. Understood? Now what is this alpha? What is this beta? I don't know. This can be anything. Alpha can be even 0, it can be even a fraction. So whether it is a fraction or it is anything it can be. So we don't know whether it is not. Did you understand it? So in case of law of mass action, which is a theoretical concept, we are just checking out the reactions and we are telling that yes, this will be my answer. But from here we cannot just see the reaction and tell no, this will be my answer. This is not possible. Clear? So whatever we are seeing, it may not be the actual answer. It can be a little bit changed. Understood? Okay. So please mention alpha and beta may not be equal to x and y. Clear? Alpha and beta may not be equal to x and y. So there is no compulsion that it has to be equal. Okay, it can be different because it is an experimentally determined value. Understood? Clear? Now you will ask me what is this k? I wrote something which is called k. Then what exactly is this k? So I am removing this k for now. I am writing this as proportional sign. K I am writing the next page. So rate proportional. I by proportional to that. Now I am writing the equation rate equal to proportionality sign removed. So a to the power alpha and b to the power beta. This k is called specific reaction rate. What is it called? Specific reaction rate. Specific reaction rate, or simply it is called rate constant. What is it called? Simply it is called rate constant. It is called rate constant. What is the definition? It is the rate of reaction when the concentration of the reacting species is unity. When the concentration of reacting or active mass of reacting species is 1 or unity, the reaction of the rate of the reaction will be called as specific reaction rate or rate constant. Clear? Clear? Okay. Rate constant cannot be changed by increasing the concentration. Very important. Rate constant K. Rate constant is independent independently likhi, correct one. It is independent of concentration of reacting species. It is independent of the concentration of the reacting species. Understood? Rate constant is independent of concentration of reacting species. It only depends on temperature. If you increase the temperature, it will change. So it is fixed for a reaction at a particular temperature. It is fixed for a reaction at constant temperature. Clear? So rate constant K, rate constant increases with temperature. Okay, so if rate constant increases, then the rate of the reaction will also increase. Understood? Clear? Understood? Next, what is the unit of this rate constant? This rate constant's unit is very important because the unit of this rate constant will differ. The unit of this rate constant will differ according to the order of the reaction. Now I will say, what is the order of the reaction? You will ask me, what is order of the reaction? I am telling you. But first let me just discuss about the unit. See, unit of concentration you all know, it is mole per liter. So according to this value, that how many of them are present and what is the power, the unit of rate constant cannot be determined. Okay, clear? So first we have to divide the equation, that is which category the equations are falling in, then we can tell the rate constant. So to do that, first we need to know what is order of the reaction. So what is order? Just sometime before we have seen in law of mass action, these values were same. So x plus y we have written, done. But here this is alpha and beta. What are these alpha beta? We don't know. So this alpha beta is known as the order of the reaction. So what is order of the reaction? Definition I am not writing. I am just telling you. No one will ask you also. Order of the reaction is the power to which the reacting species is raised. Clear? Order with respect to that reactant. Understood? Order of the reaction with respect to that reactant. Order of the reaction with respect to that reactant is the power to which that reactant is increased, is raised to in the rate law. In the rate law. Done? And the power, all the powers, there is power of this reacting species and B reacting species, C, D, etc. All the powers if you add up, then you will get the overall order of the reaction. Clear? However, remember this, that the order of the reaction with respect to someone will be the only power of that particular person. Okay, but if it is asked overall order of the reaction, then add up all the powers. Simply. Clear? So order of the reaction of this reaction, order of reaction will be alpha plus beta. But if I ask you, I am writing it all here, order with respect to A, then alpha. Order with respect to B, then beta. Clear? So if it is asked order with respect to A, then only alpha, not beta. Clear? But it is an order of the reaction, then we will call it as alpha plus beta. So based on these values of alpha plus beta, we have classified our reaction into different orders. First order reaction is called zero order reactions. Most reactions occurring in our universe are all first order reactions. Very less they are zero order reaction. But we will study in our syllabus only two type of reaction. One is zero order reaction and second one is first order reaction. Okay. Zero order reaction means the order of the reaction will be equal to 0. Order of the reaction means the summation of alpha plus beta. So if it is a zero order, then alpha plus beta must be equal to 0. That means if I write the rate law, then what will be my rate law? Then my rate law will be rate proportional to, if reaction is remaining same, let us assume the reaction is A plus B forms product, or let us take only one, two products, two reactants will get disturbed now. A to product. Clear? From a reactant A, it forms a products. Okay. So if I write the rate of the equation, then rate will be equal to K times rate proportional to this. So rate equal to K times A. But this is not zero order reaction because nothing is in the power means 1. But it is not a first order reaction, it is zero order reaction. So A to the power 0. So A to the power 0. So that means ultimately rate is nothing but equal to rate constant. Understood? So for a zero order reaction, rate is nothing but equal to K, equal to the rate constant that we have for the particular reaction. Understood? Understood? Clear? Example, one of you remember from here, one example you have to remember, that is decomposition of ammonia. Okay, decomposition of, because reaction they can ask, decomposition of ammonia over surfaces of, decomposition of ammonia over surface, platinum surface. Okay, Decomposition of ammonia over platinum sulfate is an example of zero order reaction. Now what is the unit of this K? Then the unit of this K is given by unit of K. In general, I am telling you, in general, unit of rate constant, unit of rate constant given by mole per liter whole to the power 1 minus n second inverse. Understood? Mole per liter to the power 1 minus n and second inverse. N equals to order of the reaction. N equals to order of the reaction. So whichever order is the reaction, you just put the value of n and find out the value of rate constant. Simple, clear? Sorry, unit of rate constant. Understood? So let us assume this formula over here now. So mole per liter to the power 1 minus n and second inverse. So mole per liter to the power 1 minus 0 second inverse. So my unit becomes mole liter inverse second inverse. Clear? Understood the unit of K? Now these are easy things. Next, first order reaction. First order reaction. We will study in our syllabus only two type of reaction. Zero order reaction and first order reaction. Okay, let us start. If we have started with zero order, let us continue zero order, then I am going to first order. Fine. Okay. Now we are going to zero order only, let's continue. Then I will come back to first order later on. Okay. Under zero order reaction, now we are going to study about the integrated rate equation. Now we will study about integrated rate equation. Using this equation, we found out that there was no work happening. So to make it easier for us to study that particular reaction, we integrated that rate equation. So it is called integrated rate equation. This is the first time you are doing integration in chemistry, I hope, or you have done in thermodynamics a little bit. So integration, you have to apply over here this integrated rate equation. We will use this equation once again. We have seen rate equals to K. This equation, rate equals to K. That only I will add in the next page. See, rate equals to K. So what did we get? Rate equals to K. Now how to write this rate? We have learned in the first part of this chapter only. Then how to write the rate? Rate can be written as minus, since concentration of reactant decreases, so minus D of A. Concentration of A divided by concentration of D equal to K. Right? This you have learned in the first part only. Achha. Now the reaction given was A to product. Given reaction is A to product. A to product. Done. So can I write at T equal to 0? That means at time 0. At time 0, let us assume that the number of moles is A. The number of moles of product will be 0. This value of A, I am assuming it as the concentration, I am assuming it to be A0. And okay, fine. A is the number of moles which I am assuming it to be the concentration A0. Next comes time T equals to, let's take time T equals to T. At certain time T, at certain time T1, at certain time T1, there are X number of moles dissociated. Clear? At T time, X number of moles are dissociated. So the value of A will be now A minus X. It will no more remain A because X moles dissociated. Product form will be X. Clear? Understood this one? Okay. So this A minus X, I am assuming it to be equal to AT. That is time T. At time T, the concentration is AT. Clear? And when it will become T equal to infinity, then when reaction will get completed, then this will become 0 and this will become A. But that case we will not take up, not needed now. So did you understand what is A? A0, what is A minus X? A. Now let us move on to the next page. So this minus dA by dt equal to K. So can I write this as d of A equal to minus K dt. Now if you have learned a little bit of integration, then I can integrate this section, I can integrate this section. Definite integration I will do. So integration from A0 to integration A of T. Okay, and this integration will be from 0 to T. Okay, from 0 time to T time, whichever I have done. Here I have taken T1 time, so T1 time, but I will take T time only. Or T1, no? Okay, let's remove this T1, otherwise you will get confused. It is T time, huh? At time T. Okay, so now let's integrate. So integrating it very easily. So integration of dt, integration of dx will give you x. If you don't know this much integration, there are too much problem for maths exam on third. So dx equals to x. So this integration will give me a of t minus a of 0, upper limit minus lower limit, equals to minus k times t, right? Minus k times t. So this I can write it as a0 initial concentration minus final concentration equal to kT, and this is exactly my integrated rate equation. Very important rate equation. Okay, this equation is very important. It will be used to simply solve questions. Based on this formula, question will be given. We'll simply be able to solve this. Clear? So this is called integrated rate equation. What are these? Integrated rate equation. Okay, integrated rate equation for clear. Now using this formula, you can solve the numerical. Suppose it is given at the concentration of initial concentration is this and concentration reactant is given this. Find out the rate constant. Use the formula. Clear? Any more doubts? Doubts? Doubts. Good. Next. Next we'll have another term which is called half life. This you somewhat have learned in radioactive. Half life means time taken to complete 50% of the reaction. Time taken to complete 50% of the reaction. So what will be the time taken to complete 50% of the reaction? Now if you use your common sense, if 50% of the reaction is completed, then that means AT will be equal to what? A0 to, so 50% reaction is done, no? So AT, its final concentration will be equal to A0 upon 2. So AT equals to A0 upon 2. Okay? Okay. Now use this formula to find out the previous equation. It will become T half. This is T half T 50. Okay. So in the previous equation, we have A0 minus AT equal to AT. Can I write it as A0 minus A052 equal to AT? So from here I can write A0 by 2 minus 1 equal to T half. Can I write it plus A equal to 40 T half equal to A0 upon 2T. This is our formula which is going to straightforward use when question is asked. Find out the half life of the equation or find out the rate constant when half life is given. Clear? Now it has many doubt. Easy? Easy, right? Yes, easy. Good. Okay. Now you have to draw some graph. Whether the graph will be asked or given in the question paper, that I don't know, but you should know what the graph will look like. So if I take up a graph of concentration, that is A, versus time, then what will be my graph look like? How will you identify how will you know what the graph looks like? Then you have to use the equation. See, find out this equation. Concentration minus concentration equal to Kt. Does this not look like somewhat of y minus mx plus c type of graph? This looks like y minus mx type of graph, right? This looks like y minus mx. This does not look like, but this looks like. So if I use y equal to minus mx, see this equation looks like y equal to minus mx plus c. Does not look like. Let me tell you how this is looking like. The equation was given as AT equal to minus KT plus A0. This was the equation. So this is y, this is minus mx, and this is c, right? So now you will say that why did we take AT as the y and not c, this A0 as the y? Why? How will I take? Initial concentration will be the value on this y-axis when we take the final time t. Clear? So if we take concentration at any time t, then the value will be the value on the y-axis will be giving me the value of the initial concentration. So any time it means, suppose the graph goes like this, the graph will go like this. So this point, wherever it is meeting the concentration axis, this will be my initial concentration A0. After that, the value will keep on decreasing. This entire intercept will be A0. That is only what is shown. Clear? So the graph keeps on decreasing. Why it keeps on decreasing? Because of the equation. There is a straight line with decreasing slope. So this slope is equal to minus k. Okay. This type of question also they can ask. The slope is equal to minus k. Next they can ask you rate of reaction versus time, not time. Rate of reaction uh, versus concentration. Rate of reaction versus concentration. Rate of reaction versus concentration. The graph will be this way, right? One tight slab. How the graph will be this way? The graph will be this way. Why? Why? Because just now we have defined the rate of the equation for zero order is equal to k. And how it will be equal to y equal to mx type of graph? How it is y equal to mx type of graph? It is not dependent on your concentration. We are jabardastly making it a dependent on concentration. Number one. How? Clear? Another important graph that is there from this part, this zero order part is the graph between T half and initial concentration A. The graph between T half and initial concentration A0. This time is initial only. The graph will go like this because we have seen the equation of T half is T half equal to A0 by 2K. Directly proportional. Clear? So we can say that rate constant for a zero order reaction is not dependent on any reaction concentration, right? Because we have seen the equation is rate equal to K only. Second, we can say half-life is dependent on the initial concentration, is directly proportional to the concentration. Okay. Oof. Clear. That's done. Now let us move on to the first order reaction. So what is the first order reaction? You can understand that the order of the reaction will be 1. So that means if I have a reactant A and that becomes a product, and at t equal to 0, if the moles are A, then this will be 0. If t equals to t, then this will become A minus x, this will become x, and t equal to infinity, then this will become 0, this will become A. But that we don't need. This value I am taking to be A of 0. This value I am taking to be A of t. Okay. First few points let us discuss. Which points we told there also, we discuss here also. Rate and example. Okay, rate example equation. Fine. So what is the rate of the equation? So I can say rate proportional to this time a to the power 1. That means rate proportional to a. So I can write the equation as rate equal to k times a. Clear? Okay. Next is example. Example, there is no limit to the example because most of the reaction or maximum reactions occurring over here are all first order reactions. So any common example you can think of, those are all examples of first order reactions only. Okay. Those are all examples of first order reactions only. For example, let me give you one example. This reaction you have done in class 10. Ammonium nitrite reaction gives you N2 plus water. Right? Please balance the equation. I don't balance it, I think. 2. Right? This is the equation. Suppose it is ammonium nitrate, then Lappiness N2O. Anyway, so this reaction is a first order reaction. That's all. Next, unit. What will be the unit of rate constant? As I have told, unit of rate constant is given by mole per liter to the power 1 minus n. So mole per liter to the power 1 minus 1 second inverse. So you can see this is getting cancelled out. So it will be second inverse. Clear? So by checking out the unit also, if in the question paper it is not mentioned which type of reaction, then by checking the unit you have to know that which type of reaction it is, which order reaction it is. Understood? Okay. Now let us come back to it. Rate equals to minus dA by dt, right? That is equal to this time it is equal to k times a. Previously this a was not there. So this integration is ln's integration. Okay. So this will become d of a equal to divided by delta divided by a equal to minus k dt. Okay. Now integrating this side from 0 to t, and this integration will take place same way a0 to a of t. Okay. So let us integrate. So this will become ln a of t minus ln a of t by a of 0 equal to minus kt. Correct? Ln at by a0, why you understood? Because it is the equation that we are talking about. So ln at by a0. This I can now write in the form. This can be written in two different ways. I am showing you. This I can write it as ln at minus ln a0 equal to minus kt. Right? So this equation I can transfer it in this way also. So let me just copy this slide because I will need this slide once again. Just give me 1 minute. Let me just copy this slide. Again, I have to write everything. Okay. So this I can write next step. I can write it as ln at equal to ln a0 minus kt. Okay, or I can write minus kt multiplied. Anyway, this will become my y-axis, this will become my c, and this will become my minus x-axis, minus mx-axis. So this graph will also be a descending graph. So if I draw a graph of, I am drawing here only because just now we have discovered the equation. So if I draw the graph of ln concentration versus time, then the graph will also look like this. Correct? So but this concentration is not concentration versus time. This is log of concentration, not even normal log, natural log. If it is normal log, then no problem. This slope will become minus k, right? But if it is a normal log, then this slope will become minus k divided by 2.303 because log has to be removed. Ln has to be converted to log. So it will become minus k divided by 2.303 or minus k by 2.303. Okay, so please remember, if this is log, we will see log, we will see ln, we will see ln. Okay, this was one format we can write. Second way of writing this equation I am showing you. Convert this in the form of e. So can I write this as e by 0 equal to e to the power minus kt? Log property. According to log property, I can send this to that side too, right? So I can write at equal to a0 times of minus e to the power kt. Another very important reaction thing I forgot to say, just now I recalled it. Here I am writing all radioactive reactions, all radioactive decays are of first order. Clear? All radioactive decays are of first order. Radioactive decays are of first order. That's now I recall, so I just remember. So at equal to a0 times the a1 minus kt. So now please use your big common sense. If I ask you to draw a graph of concentration versus time, only concentration, not a concentration, not log of concentration, only concentration versus time, then the graph will be an exponential graph. Clear? Then the graph will become an exponential graph. So please remember, the graph will become exponential graph. Previously it was just y equal to minus. Done? Clear? Okay. Now coming to t half. So as we have seen the equation already, that in the equation we had ln of a0, ln of at by a0 equal to minus kt, right? So at t half, we know at will be equal to a0 upon 2. T will become t half. So let us write t half's equation, ln at a0 by 2 into a0, right? So equal to minus k t half. So I can write ln of, this will get cancelled out, 1 by 2 equal to minus k t half. So I can write this as minus ln 2 equal to minus k t half. Minus minus cancel. So I can write t half equal to ln 2 by k. Very very important, ln 2 by k. What can I infer? T half is independent of the T half is independent of rate, not rate, no, sorry, concentration of, not concentration also, initial concentration of reactant. Clear? Very very important. T half previously was directly proportional to the case of initial concentration. This time, no, it does not even depend on that. So if I ask you the graph for first order reaction, will you mention T half versus concentration? Clear? T half does not depend on concentration. Previously it was straight line in the y equal to mx type of graph, but this time it does not even depend on that. So please make sure that you all know all this, huh? Because very very important questions, directly they ask you these questions. Okay. One more important thing I have to tell you, then this part will be done. It will be writing a different color. Very very important. Only for first order reaction, amount of substance. This can be asked in your MCQ. Amount of substance left after n half-life. Amount of substance left after n number of half-life equals to concentration initial upon 2 to the power n. Very, very important. Clear? So amount of substance left after n number of half-lives will be equal to A0 divided by 2 to the power n. Remember, this is only for first order reaction. Any other reaction do not apply this, please. Amount of substance left after n number of half-life will be A0 by 2n. If I ask you amount left after one half-life, A0 by 2. Amount left after two half. Clear? This chapter is very easy. I'm telling you, this chapter is very easy. You can read every level 5. This chapter is nothing. Actually nothing. Okay? Now we are coming to the last part of the chapter. Experiments have told us that in general, for every 10 degree rise in temperature, every 10 degree rise in temperature, comma, rate is nearly double. If not nearly double, almost double. Okay. So for every 10 degree rise in temperature, rate is nearly double. Rate is nearly double. Clear? So from here we are defining one term which is called temperature coefficient. Temperature coefficient. Temperature coefficient is basically defined as the ratio of rate at higher temperature. So that is rate constant at T plus 10 degrees Celsius divided by rate constant at T degrees Celsius. Clear? So it is a ratio of two temperatures which are separated by 10 degrees Celsius. This is temperature coefficient. From where? Never have seen a question. Next. Collision theory. According to collision theory, it states that the reactant molecules change into products only when they collide with each other. So products are formed when reactant molecules collide with each other. So according to collision theory, products are formed only when they collide with the reactant molecules. The products are formed only when they collide with the reactant molecules. So products are formed only when they collide with the reactant molecules. Clear? Who are the they? When reactant molecules only collide, not they will seeming like products are colliding. No, products are formed only when reactants collide with the reactant molecules. That means the molecules interact with each other. Then only they will form the products. But in that case, then everyone who is going to form product is also not there. Right? Only effective collisions can form products. Okay, only effective collisions can form products. That means the collisions which have appropriate amount of energy and a proper orientation, they can only form the products. Everyone cannot come and form the products. So what do we mean by effective collision, or how can we collision be called as effective? Threshold energy. Term is called threshold energy. Threshold energy to cross energy barrier and cross orientation barrier. So only effective collisions can form products, means they should have the minimum amount of energy which is required to break the bonds and form the products. Minimum amount of energy should be there which is required to break and form the products. Break the original bonds and form new bonds and form the products. So this is called energy barrier. Second type of barrier is called orientation barrier. the molecules have to be properly oriented so that the proper products are formed. Random unnecessary products that are formed that is not of my use, that is lost. So orientation barrier is also important because it forms the correct product. So these two barriers have to be crossed in order to have effective collision. Clear? Understood? Okay. This threshold energy is only called as activation energy. Another name is given activation energy. Activation energy is basically the energy, the excess energy which you need to cross the energy barrier and form the threshold energy. Clear? So it is activation energy, the energy that is required, the energy that is required to cross the energy barrier to change into products. So please read the definition of activation energy. Very, very important definition. Okay, activation energy. Next, coming to the type of reaction. Exothermic and endothermic. First, let us discuss exothermic reaction. What you need to read under exothermic reaction basically, what is an exothermic reaction? Heat evolved. Heat evolved. So, in an exothermic reaction, we find that the heat is reaction. So, why is the heat evolved? Because enthalpy, class 11 thermodynamics. Okay, enthalpy of reactants greater than enthalpy of products, greater than enthalpy of, clear, enthalpy of reactants will be greater than the enthalpy of products. That is why heat will be evolved. So if I calculate the delta H for the reaction, then that will be H of product minus H of reactants. We have learnt in class 11 thermodynamics. So this will be my negative value. This will give me a negative value. So please remember, delta H is negative for exothermic, positive for endothermic reaction, not the vice versa. Please, please, please. Okay. Acha. So if I draw the energy diagram, main thing is the energy diagram. So if I draw the energy diagram, then how will my energy diagram look? Suppose my reactant is over here. This is my reactant. Then my product will be a little bit below. So that means my energy, suppose this is my energy barrier. Then my product will be somewhere over here. So this is my energy barrier. If I draw the line, then for the reactants to get converted into products, this much energy barrier has to be crossed. This energy barrier is only called activation energy, represented by EA, activation energy. Okay, this energy is called activation energy. Clear? And this is called the delta H. The energy that is released in the course of reaction. Okay. Okay. Clear? This is the delta H which is released during the reaction, the extra energy that is released during the reaction. Okay, this is an exothermic reaction graph. Exo. Understood? Any doubt? Achha. One more thing, let me add over here. Delta H, that is enthalpy change at constant volume. This also you have learned in class 11 thermodynamics. Enthalpy change at constant volume is delta U, that is change in internal energy. Change in internal energy. Right? At constant volume, if I talk about the change in enthalpy, then that is the change in internal energy. Delta U equals to delta H at constant volume. ठीक है? Heat of formation. Okay. Next we will come to endothermic reaction. Endothermic reaction. Endothermic reaction means heat absorbed, right? Or heat used up. So if heat is absorbed, then what will happen? Enthalpy of products will be more than enthalpy of reactants. So enthalpy of reactants less than enthalpy of product. So in this case, delta H will be equal to E of H of P minus H of R, which will be a positive value, right? Please remember that enthalpy change is positive for endothermic and negative for exothermic. Okay. So one more point I have added over there. No, what was the point? Concept is not required. Okay. No, concept we not discussed over here. Fine. Last time we discussed it, not required now. So the graph will look like energy band diagram, reactants, products. Okay. Heat absorbed. This is a heat absorbed. Then it went to higher state. Energy barrier crossed is EA. Okay. Clear. Clear. Okay. Easy. Very very easy to remember this chapter. Done. Okay. Endothermic exothermic reaction cleared up. Acha. Next. This top, this peak is called activated complex or transition state. Remember this. I don't think they will ask you any question. But in case they ask you any question, this top will be called as transition state or activated complex. This point is called transition state, okay, or activated complex. That means it is that state where it has highest potential energy of the system. Okay, so this state will be called as activated complex state or transition state. That means it has highest potential energy. Just remember this point, important. Highest potential energy. If it is having high potential energy, then it will always try to lower it. So this is unstable, highly unstable state. Okay, this is highly unstable state. Activated complex, highest potential energy, highly unstable state. So this is seen for a very fraction of time. Okay, clear? Achha. So what does exactly a catalyst do? As I told you that I will tell you catalyst topic later on. So exactly what does a catalyst do? Please note down. Catalyst lowers the activation energy. Catalyst lowers the activation energy. Okay. So how does catalyst increase the rate of reaction? By decreasing the activation energy. As simple as that. So activation energy decreased, rate of reaction increased because it has now alternate path. How? Now question is how? Complex lowers, catalyst lowers the activation energy, but how? Forming complex. So very very important, forming unstable complexes. Okay, so it forms unstable complexes due to which the activation energy is lower and it finds an alternate path and the reaction proceeds easily. Clear? Clear? Next we'll read about some formulas. Two formulas I will tell you. First one is K equal to A K equals to A e to the power minus EA by RT. This is according to Arrhenius theory. Huh? This is Arrhenius equation. Remember this? Arrhenius equation is this equation K equals to A e to the power minus EA by RT. This shows the dependence on temperature and rate constant. Okay. So this equation can be written as, if I take this towards this side, then I will get K by A equal to e to the power minus EA by RT. So this can be written as ln, if I take it as ln, then ln k minus ln a equal to minus E by RT. Correct? Right? So I can write this as ln k ln a ln k equal to minus E by RT. They give in this format and they give some values and they ask you to find this EA value. So using this formula you can easily find that out, no doubt at all. Okay, the last formula they will be telling you, that is again temperature only, K2 upon K1, Arrhenius equation only, log K2 upon K1 will be EA by 2.303 R 1 by T1 time minus 1 by T2 time. Clear? Very very important. This formula based question one is asked usually, that rate constant at this temperature is given, at this temperature is given, you just find out the value of activation energy for the reaction. Clear? You can just put the formula, use and calculate properly. Do not make a mistake in the calculation. Okay, R is 8.314. It will be given in the question paper. If you have any doubt, ask. It will be given in the question paper. If not, then ask. Okay, you need to do that because it should be given in the question paper. Okay, clear? 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 Okay. One small topic I will discuss, then I'll end the video. It is pseudo first order reaction. What is pseudo first order reaction? Pseudo first order reaction. What does the word what is happening is false is that reaction appears to be of higher order, but it is fine. It is first. Okay, so reaction appears to be of a higher order reaction, but actually it is a first order reaction. This is called pseudo first order reaction. One example, you have to read acid catalyst hydrolysis of ester. In organic chemistry also you are reading this. Acid catalyst hydrolysis of ester. Right? So CH3 COCH3. Okay, plus water in presence of some acid forms CH3COH plus CH3OH, right? So you can see here if I write rate equals to K into water into CH3COOCH3, right? But here it should be 2, but here we will see that water's concentration is 1. Very, very important. This we have taken also in class 11 chemical equilibrium. Then water's concentration is taken up to be 1. So since water's concentration is 1, then the overall reaction's order becomes 1 and not 2. Clear? So reaction appears to be of higher order, but actually it is a first order reaction. Okay. Next and the last topic of this chapter, it is molecularity. What is the topic? Molecularity. Very, very important topic. Molecularity. What exactly is molecularity? Molecularity is basically the number of reacting species. What is molecularity? Number of reacting species taking part. Number of reacting species taking part. Okay. The number of reacting species taking part in a reaction will be called as molecularity. Molecularity is a theoretical concept. Molecularity is a theoretical concept, while order is a experimental concept. Difference is asked. Number of reacting species taking part, it is a theoretical concept. Next, it can be any whole number, any real number. It can be any real number, but never a fraction or negative. Okay, actually real number does not include negative, but I told it. Molecularity can be any real number, but never a fraction nor negative, or 0 is not a real number at all, so we will not say that. Clear? Writing still all 0. So molecularity can never be 0, molecularity can never be a fraction, molecularity can never be negative. Next, molecularity, theoretical concept. Molecularity is not defined. Next point is molecularity is not defined for complex reaction. So molecularity is not defined for complex reaction. What is a complex reaction? Reaction occurring in more than one step. Reaction occurring in more than one step. So it is not defined for a complex reaction. So why am I writing this? Because question will be asked on difference between molecularity and order. So I am writing the order of a reaction also here so that you can differentiate it easily. Order of a reaction, if I first talk about, then what is the order of a reaction? It is the sum of the power, right? It is the sum of the powers of reactants in rate law. In the rate law, the reactants power will be the order of that reactant, right? Next, it is a experimental value. It is an experimentally determined value, not a theoretical concept. It is an experimentally determined value. Next, it can be negative, 0, fraction, Right? Previously I said only real number, but here it can be negative, it can be zero, it can be fraction. Fractional orders are also possible. Okay. And last point. What was the last point we wrote over here? Not defined. It is very much defined for. It is very much defined for a complex reaction, and that is where the order is not same as the given value. So it is defined for complex reaction. It is defined for complex reaction. And one important point I am mentioning it, for elementary reaction with single step reaction. For elementary reaction, order equal to power equal to stoichiometric coefficient. Okay. For elementary reaction, whatever is the stoichiometric coefficient, that will be only the order of that particular reactant. Clear? But only for elementary reaction. For any other type of reaction, that is a complex reaction, is not defined. Okay? So that's all. We have revised the entire chemical kinetics chapter. Clear? I hope you have liked the video. You have also revised the chapter. I have also revised the chapter. So all the best for your upcoming chemistry exam on Monday 24th.